and today we're going to be going over how to do a distribution fitting analysis in HEC-SSP. And the motivation behind doing this distribution fitting analysis for us specifically is that we're using it to analyze if the Bulletin 17C analysis distribution, which is the log Pearson type 3, is actually the best distribution for this data set that we've pulled from the Johns Creek stream gauge. So the first thing we're going to do is we're going to click on distribution fitting analysis, and we're going to right click and create new. We're going to call this distribution fitting analysis. Again, we can give it a description if we want. I'm just going to choose the data set that I want. And the first thing I see here is that I have this data tab that is showing me just my raw data. So I have this original data and this filtered data. I know that my parameter type is my flow, and I also see that I have 3 graph types for the data. So I have my CDF, which shows my increasing non-exceedance probability, my PDF plot, which just shows my relative probability, and then of course the scatter plot here. So next I'm going to go over to the analysis tab, and this is really where the bulk of work is going to be done in figuring out which distribution best fits this data set. So the first thing we see is that we have this distribution filter on, and we're filtering what distributions are showing up based on a parameter, which is fine. We're going to go forward with that. When I'm looking at these columns here, the first thing I notice is that I have a bunch of different distribution types. So we went over 5 distribution types in class. We have our generalized extreme value, the Pearson 3, the log Pearson, the log normal, and the normal. But as you can see, there are definitely a bunch of different other distributions that you can choose from in HEC-SSP. And over on the right side, another great functionality that HEC-SSP has is these test statistics. So it will automatically calculate these test statistics that will tell you how well the distribution is actually fitting the data set. So as we can see, these test statistics are increasing, which means that as we go down the list, they are getting, the distributions are getting more and more not fit to the data. So as we can see, for this first test statistic, generalized extreme value is the best one. But if we go over to chi-square, I see that now it's this ln normal. So what do I do about the fact that I don't really have a very obvious distribution that is the best? Well, what I would do in this situation is I would sort of take a rough average of both of them. So if I give all of these a rank based on what their test statistic is, so for generalized extreme value, obviously the rank would be 1. And then I go over to the chi-square, and the rank would be 4. If I take the sum of those and take the minimum of that data set, that's going to be my best overall average distribution here. So when I go through that process, I actually find that the Pearson 3 is the best fit to the data set based on both of these. So I'm going to go ahead and choose the Pearson 3 first by displaying over in this column that is labeled Display All Curves. If I click over here, I can see that it gives me a line with points on it that is showing me the Pearson 3 distribution here. And I have my CDF, my PDF, as was shown in the data, the PP and QQ plot, as well as the CDF plotting position, which is something you're going to have to print out in the assignment. So once I've decided that my Pearson 3 is the distribution that I'm going to use, what I want to do is I want to click this button called Accept Selected Distribution. So what that's going to do is sort of like how we have to press the compute button to actually run our analyses for the flood frequency and low flow. This is the similar process where in this results tab, we will actually get this frequency curve data populated. And it will actually run this distribution. So we don't have to go and run another general frequency analysis or some other type of analysis. It will basically do all of that work for us in here in this distribution fitting analysis. So I'm going to go ahead and accept the selected distribution. And this computation process will probably take about 3 to 4 minutes. So when we come back, we're going to talk about how we're going to export our plots and export the rest of our data. All right, so after about 3 to 4 minutes, our confidence limits and our expected probability curve have been calculated. And now if we navigate over to the results, this is where we can actually output our data. So We can output our CDF plotting position by coming over to results, and we can double click right over the plot and it will pull up the same plot window that we've seen in all of our different frequency analyses. We can go ahead and always print or save as a PNG or a JPEG. And same thing, of course, we can always come over to View Report and it will have all of our data calculated and laid out for us, our input data, what type of analysis it was. And we can always print, save as, whatever needs to be done to output our data. So that is the end of this tutorial. What you're going to need to do with this sort of data is compare it to your results from the Bulletin 17C analysis to see if there's any real discrepancy and how that might affect your design if you were using this for design. So that is the end of our tutorial series, and we'll be applying these types of analyses to stationarity concepts and trend analysis later on in the course.